Okay, this is problem 363 in the problem solving videos, and in this problem we're going to find V0 using mesh analysis, and we're going to be using the problem solving strategy on page 117, and it starts out and says to assign a mesh current to each independent loop, and we're going to do the following assignments. We'll assign current I1, current I2, and current I3. So now we've assigned a current to each independent loop, and if you'll note, then we have three unknowns: I1, I2, and I3, and we're going to have to write three equations to find those three unknowns. And remember, what we do is we apply Kirchhoff's voltage law to each mesh to write those equations. So let's start, for instance, with mesh number 1. Let's apply KVL, and I'm going to write voltage drops associated with resistances, and then we'll have the sources involved in that too. So let's start and work around this mesh clockwise. So we have a drop 2KI1. That's a drop across the 2K resistor. Then we have a drop across the 3K resistor. That's 3KI1. Now when we come around to this resistor, it has two mesh currents in I1 and I2. If we write that as a drop, we would write it as 4K times I1 minus I2. Okay, if we want to write it as a drop going around clockwise, there's a voltage polarity that we would need, and then we would need the current flowing in that direction to write that as a drop, and that current is I1 minus I2. Continuing around the loop, we'll have a drop across this resistor that's 3K I1 minus I3. And here's a voltage source. This is also a drop, so we'll write that as plus 8. And then as we move around to this source, we'll have minus 10 equal to 0. So there's our equation for mesh 1, and if we simplify that, we'll have 12K I1 minus 4K I2 minus 3K I3 equal to 2. So there's the first of our three equations, and to get the other two equations, we're also going to apply KVL to those other two meshes in the circuit. So now let's do mesh number 2. Okay, and if we start up here in this corner and go around clockwise in the direction of the mesh current, we'll have 4K I2 minus 12. Again, we're going to write this as a drop, and to get it as a drop, we have 6K times I2 minus I3. And then if we come on around to write this as a drop, we'd have 4K times I2 minus I1 equal to 0. So if we're going to write this as a drop going around, we'd have that voltage polarity, and then we'd want the current flowing up, which is I2 minus I1. Now, if we simplify, we have minus 4K I1 plus 14K I2 minus 6K I3 equal to 12. There's our second equation. And then to get our third equation, we're going to apply KVL to mesh number 3. Okay, so if we start here and go around clockwise, we'll have 6K I3 minus 8. Then we'll have 3K times I3 minus I1. And then we'll have 6K times I3 minus I2 equal to 0. And if we simplify that, then we'll have minus 3k I1 minus 6k I2 plus 15k I3 equal to 8. So there's our third equation. So now we've got our three equations, and now we're ready to solve. Okay, so let's write them in matrix form and then solve them using MATLAB. So our equations in matrix form, and we have our vector here, I1, I2, and I3, and then here's our voltage vector. So here are our equations now in matrix form. And then note the symmetry of that matrix, and that's because we only have resistances and independent voltage sources. So now, using MATLAB, we get the following. I1 is 1.418 milliamps. I2 is 1.825 milliamps. I3 is 1.493 milliamps. And if you refer back to the circuit, you'll see that V0 is 6K times I3. So we have 6K times 1.493 milli, and that gives us 8.958 volts.